talking about this in JavaScript, which probably should have gotten its own highlighting. And here are our objectives for the day. We want to be able to answer Dan Abramov's question. And here I've had it pulled up. 2 seconds on Dan Abramov. Does anyone know who this guy is? Yes, he's working React.js, very good. He explains with words and code, very good. So he is on the Facebook React team, literally developing for React, and is the creator of Redux. So this is the person that you'll respect because he created Redux and is currently working on amazing React features. But you will also, for 2 seconds while you're learning Redux, just absolutely hate the man because when you first learn Redux, it's a lot to take in. And then you will realize his absolute genius, and then you'll be like, oh my God, Dan Abramov, you're the best. That usually happens. So, cool. He works on React, and he built Redux. So this is kind of why some people care about what he tweets and what he thinks about. But this one's actually pretty important. And that is, there's something different about these two things. Here we've seen how we can take an object, right, and call or invoke methods that are attached to these objects. And then there's also this idea that we can store this method into a variable and then invoke that method this way. I did it already. We can invoke it in the manner that looks like that. Oh, that's terrible. That didn't work out. I'm sorry. But those two are different. And we will learn and understand why. Does anyone have an idea how they could be different right now?
When you're invoking the second one, you're invoking it long reference to the object as opposed to directly on the object.
Absolutely. So what Harlan said was that you're invoking the method here, and you're invoking the function named method versus the method that's attached to the object. That's going to sound crazy, and that's okay. Let's learn a little bit more about it. Let's go back and explore to see if it makes sense later. All right? The idea is the context execution, where it is executed and when it is executed will matter significantly. So let's take a look. All right? We'd like to review self and this since it'll get us about 40% of the way there in the way that we understand how this works. Please recognize and value the differences. And really, when is this set and when is it not set is the main question we have to be able to answer today. Cool? Are we good on these objectives? These SWABOTs, the students will be able to, haven't heard that in a while, right? A little throwback. I would say like 90s throwback, but like, let's be real, that was like 4 weeks ago, right? Let's talk about self. Do you guys miss me? I miss being like this. Feel free to make fun of me. Already don't care. All right. So, pretty standard person class, right? Boom. We have the attr accessor for name, which builds what again? Super fast review. The reader and the writer. Cool. All we have is these attributes, attribute, name, and then it says self.saySomething. So in this context, what is self in this person class? It's the person class, right? So here, where it's defined, it's important, and what it's referencing is determined as to where it is defined, which makes sense, right? So because this is a class method, then we can say on the person, there's a method called saySomething that's defined. So we can call person.saySomething. This makes sense to you all, right? Therefore, when we do person.new, right, and we create this like Andy, right, we're passing this attribute, Andy.name is the instance method that was defined in the attr accessor. Can I do Andy.saySomething? No, because Andy is the instance, and I cannot call class methods on an instance. So far, so good? Now, this is just a review of self in Ruby, right? That's not too shake. I haven't like jarred anyone's mind. Cool. All right, self is not this, and we will learn very quickly why. Let's talk a little bit about the word self, a little bit about the word this, because words mean things. So when I talk about self, what am I talking about in the context of English, right? English. What is like self? Yeah, right? But really like you though, right? When you're saying self, right? Like that? No. Self is just more about inner reflection. And so when we talk about self here, inside the person class, the inner reflection, me at the time, the self is going to be the person. Where it's defined and what it looks at is pretty clear in the name self. However, let's talk about the word this. So a cheesy analogy I like to use is when I'm eating food, I'm at dinner, I'm like, this is good. And then I'm riding the subway and I hear, hey, we're going to be held up in the station, there's train traffic ahead of us. And I say, well, this, or this sucks, or I don't like this. Am I talking about the same thing? No, one, I was talking about delicious food, which I literally could not describe in words. And then the other time, I am talking about my commute. So this will change literally in the context in which I say it. Does that make sense? This will take on whatever context it's in. Like, this classroom is great. And then I could say that in an hour or two when I'm lecturing to a different mod and say, this classroom is dark. This, in each of those contexts, will refer to possibly something different, possibly the same thing. It really depends on when and where I say it and what I'm referring to. So naturally, the this keyword, the this word, will just change radically based on how I decide to invoke it, even in English. So far, so good? So everyone kind of already seeing a separation of self and this. But sometimes this and self can be the same thing. Sometimes. We'll take a look. Boop, boop, boop. I don't know why this GIF is in here. Been meaning to delete it, but it's there. I like that. I don't know why this is here. You're like, oh, wow. That was very meta of you. Thank you. I miss being back. It's probably the coffee. I fell asleep at like 9 o'clock yesterday. And then I woke up at like 7:30. I had that good sleep. You know, the sleep that you guys haven't had in a while? It was money. It was so money. I'm ready. All right, so there are 4 rules, right? And the cheesy line that Andrew and I like to say is, this is what I would describe as the main clickbait of this lecture, and that is the four rules that govern this. Understand this in 4 easy ways. Developers hate them. This is it. It's just 4 rules. If you understand these 4 rules, you will understand this. The tricky part is that the rules can be mix and matched in the way that you can stack on rules 2 and 3, and they are not necessarily exclusive, but these are all the rules. So far, so good. We're going to skip over 1 for now, and let's go with 3. So let's start with 3, because 3 looks the most, looking like a Ruby, right? And so let's just figure out what happens here. I just have a dog object, const dog, and I have 2 keys on dog, a name, and what is this key? So far, so good. Just on the 2 keys. Ja. So the name points to Winfield, right, which is like Andrew's dog. It's my friend Andrew. Like when you create these lectures, you just draw on life. So, question? Oh, cool. And what is this? The key points to what? A function. And all it does is it returns this keyword. So what are some thoughts in regards to what is this invoked? Well, let's think. It has to be something like dog.name gives you Winfield. So dog.what is this should give you a function. So I can in fact invoke dog.what is this, and I do so literally right here. The syntax you see before you, dog.what is this being invoked, will simply return the this keyword. That statement looks a lot like Ruby. It's object dot what is this. In the context of the dog object, inside the dog object, the this keyword will be dog. In the same way that self is inside the person object, self is person. So let's take a look. All right, I could just do it right here because we're cool like that. So dog dot what is this is a function, and all it does is it returns this. So I'm going to invoke it, and what? Did you see that? Oh, yeah, that's right. That's 100% correct. Whoa, I like lost my mind. It returns this, right? It returns this. I thought I was going to say something else. And it returns the dog object. So far, so good. It returns the dog object. So far, it's just returning what we imagine this and self being in the same instance. It'll work differently. The question was like, will this work differently in the arrow function? Yes. I will explain the arrow function and how it kind of handles this keyword. But for right now, I just need you to understand that this and self can sometimes look the same. Are there any questions on the context execution of what this is right now? Pretty similar. Cool. Now let's get into, is everyone good on rule number 3? All right, so let's jump to rule number 1. It's a little weird. Cool. What we have here is this function person, and it takes in a name and a favorite color. So this dot name is equal to name, and this dot favorite color is equal to color. Does that make sense to you? So inside the person function keyword person, what is the value of this? Well, we could check it, right? We could check it. So what do we think it is? Let's take a look. This is where it gets a little dicey, right? Oh man, actually let's do it. Let's do this instead. I'm going to just inside here, console log this. Is that fair? Cool. So how do I actually run it? Well, I just do person, and I invoke it with a name, like Winfield. Let's just put someone crazy. Let's put Zach. Zach's not crazy. I didn't mean it to sound like that. I'm sorry. I'm bad at English. And Zach, what's your favorite color? They think it's black for you. Ooh, blue guy. Nice. So what happens? Undefined, right? It's a little weird. Let's do this. Let's put const, right? TCF equals to, and then we'll do this. So what is TCF? Undefined. Why? What does person, the function, return? Nothing. So of course it would be undefined, right? Of course it would be undefined. Here's the weird thing. Who noticed that I put a capital P for person? Who writes their functions like this? Right? Nobody. That's weird. So JavaScript, in order to create this idea of classes, so to speak, because what does the function person with a capital P look like to you as we relate it to Ruby? It looks like the initialize. What I want you to start thinking about is, as you think about JavaScript, and we talked a little bit about this yesterday, that JavaScript can both be functional and object-oriented. The idea here is that I can create new objects with functions, just like I can create new objects with classes in Ruby. Now, there are classes in JavaScript, and we will have a separate lecture on that. But this is the idea that I can create objects in JavaScript. Cool? This is known as a constructor function. There is literally no difference in the syntax between a standard function, like a function that does this. Function, you know, cool, man, cool. Takes in no arguments, and it just console logs cool pigeon. Right? Oh my god. Do you guys know what I did? Yeah. It's hard to go between Ruby and JavaScript. It really is. So there's syntactically really no difference between something like this and this. So the only way we can determine what's different is by capitalizing the first letter. This tells me, just looking at it, that this will be a constructor function. And again, a constructor function is just a function that creates objects. And you can kind of tell because this is eventually going to create an object with these key values in it. So let's take a look. If I were to do this person, let's do const huzzah. I really want that to stick. Right, we could do in Ruby person.new. But as you remember, right, this .new, because of the dot operator, this .new, you're calling and invoking a method new on the person class. Does that make sense? So JavaScript, however, is not as object-oriented. In order to create a new person, you have to put the keyword new. And then invoke the function person. Right? So now let's put Hamza. And Hamza, what's your favorite color? Are you also a blue kind of guy? Ooh, green guy. Ooh, green guy. Cool. And let's take a look at what happens. Also undefined. Why is it return undefined? Right. There's literally no return value. However, I see huzzah here. And huzzah is just an instance of this person class pointing to favorite color and name. So I can do, oh, embarrassing. I can do huzzah dot name, and I see that. I also ask for the fave color, and I see green guy. So far, so good. This is just, the constructor function is almost a one-for-one translation to the initialize function. Notice here that it says person. Notice here that it says person, right? I just gotta do one of these, right? Versus if I were to just say, I don't know, const dog equals to, and I pass in an object literal, and I put name, and I put Cooksters, right? My dog's name's Cookies. And favorite food is, unfortunately, everything. Cool? Yeah. Fine. Everything but carrots. Cool? Some dogs love carrots. Cookies hates them. So if I were to put dog, there's something a little different about person and just this straight up object literal. Can anyone see? Can anyone spot the difference? It's this giant person word right here that comes before the object. So what that's doing, what the constructor function is doing is it will attach this keyword to the constructor function. What that means is huzzah. Inside of huzzah, if I were to add a function to huzzah as a key, let's do it. Huzzah, right? Dot new function, right? As a key. And I were to say it is equal to a function. Boop, boop, boop. And I were to console log this. Ooh, almost in that JavaScript hell. Almost. What does that line do? What does huzzah.newFunction do? It adds a new key that points to a function, and all it does is it will console log this. So if I were to invoke it, I have to, console log never returns anything. I hate console log sometimes. It will point to huzzah, the object. The person object of huzzah. You following along? I should return it. New function, clowns. Let's return it. Bloop, bloop. And just invoke it. Cool? It will point to the person. Versus if I were to do it with dog, the dog doesn't have a this to point to because it's not binded to the dog. Like this is literally, the object right here is literally an object literal that I've stored inside of a variable called dog. It has no relationship to a like dog sort of hierarchy, this dog constructor. Does that make sense? Yeah?
So if you ran this on dog, it'll just return that object literal that you assigned to it.
Kind of, but not really. What I want to do is show you what happens with this. Okay? I mean this keyword. So, all right. So far, are we cool with constructor functions and it just points to the main object? Like this inside of Andy will be the person. Versus how I just did it with the object literal for dog, it won't point to anything. Correct, because it wasn't attached to it because of the fact that it wasn't a constructor. I never did new dog and then pass in parameters. I just put dog equals to an object literal. This object literal has no relationship to a constructor function. I just created a object stored in a variable. It points to the variable, but the variable itself is not a constructor function. Cool. All right, let's see, yeah. All right, let's jump to 4, and then we'll do 2. Don't worry about the order, just there are 4 rules, right? When we talk about this, what do you think this is on the global object? Because remember, where's function being defined here? On the global scope, right? It's not being nested anywhere. So it's being attached to the global object. As we know, the global object in the browser is the window. So if I invoke, say this, and it simply returns this, it will be the window object. In the same way that if I just put this on global, it is the window object. Are there any questions as to the window object being the global object? And if I reference this in the global, it just refers to the window.
I have a question. So like in Ruby, when we were using pry and we like wanted to see like what we were, like what self was, we could just like set like in pry.
You can say self. Yep.
Can you do the same with this in like the debugger?
That is correct.
It will tell you what your scope is. Okay.
It will tell you what this is. If you are stuck in a debugger in the exact same way that you are in a bybug or a binding pry in Ruby or Rails, then you can just type in this and it will tell you what this is at that time of execution. Cool? Great. Let's talk about rule number 2. I almost said this for no reason. All right. Here I have 3 objects. Person 1, person 2, person 3. And it's just Andy, John, and Gary. Those are cool people. I have a function called sayName and takes in a location and a time. And I'm going to return a string that invokes this .name, says hello from location and time. So far, so good. This is all this does. For now, let's take this. Let's take that code, bloop, and put it right here. What I want to do is invoke sayName. What happens if I just invoke sayName? And I put in a location of New York. It's the concrete jungle. It's where dreams are made of. And what time is that? Now o'clock. Now, okay, o'clock. I don't want to, let's do it. Let's go hard in the paint. Now o'clock. That'll work, right? That'll probably work. What? Where is my JavaScript code? That is bizarre. Let's take a look at that one more time. What is this .name? Yeah, it's the first function that we wrote with Zach. I did. You're stored in there. Yeah, I have to like clear the cache. You're in here forever. Ah, man. All right. I'm having troubles with this right off the bat. That's very interesting. Here's how, well, this is an interesting learning point. Let's take a look. I attached this .name to Zach in the window object inside of this instance of the window object. Here you could see, actually let's just take a look. If you look at the window object, you can see all of the methods attached to the window. Some of them should look familiar. There are a lot, just as a warning. Let's see which one's a popular one that you might have used. Probably used a couple times, right? Maybe. Cool. There's history, there's length, and then eventually, these are like the current like event listeners on the window. There is, where is it? Somewhere here. Yeah, right? I know my alphabet. I definitely know it. Up further? Yeah, we overwrote it. That's why it's that. Does that make sense at least? We overwrote it and I literally stored it on the window object. So it's been reading that ever since. However, on a fresh window object, this .name should be empty string. All right? How did we solve that mystery? That's intense. Great. So if I invoke say name with New York and now o'clock, it makes sense that it is blank. Cool. Man, that did not go well, but I'm glad we learned that lesson. Did everyone understand what happened when I overwrote like window.name? Like here, literally, window is the window object. Is window. Embarrassing. All right. This .name. What I can do is I can set what the keyword this is by using one of three methods. And that is bind, call, and apply. So let's take a look at bind, call, and apply. All right. Call, right? Here's important. Here's what I would like to tell you. Call and apply are very similar. They are typically used in metaprogramming. Does anyone have an idea of what metaprogramming is? Yeah, using macros to write functions for you. That's a good one. Think of metaprogramming as programming to program, which is kind of inherently like meta in that sense. What I mean by that is you're writing programs so that other people can use your program to write other programs. For example, a gem. You write Ruby to build a gem so that someone else can use your gem to write their code. You might have seen this in a very popular gem called Rails, where you literally download Rails because like DHH, father of Rails, wrote a gem called Rails. You literally gem installed Rails, and then you ran Rails new scaffold, cool project, whatever. And that built out your Rails skeleton. And then inside there, you started writing routes, controllers, views. So metaprogramming is when you write programs for other programs. Typically, you will see call and apply for metaprogramming. Please just understand what they do. And at this point in your dev careers, you will not really be doing metaprogramming. You have like an idea of why? Because right now, you're just trying to get functions to work. You're not worried about writing a library for someone else to use. You're just trying to update that DOM, you know? So I'm going to go over call and apply. It's important to know what they are, but please do not stress over memorizing them. The only real one that will have any practical use for you will be bind. So let's get call and apply out of the way. Let's focus on what they do, then understand bind. Cool? So call. I can put in what I want this keyword to be in my function. So for example, say name takes how many arguments? 1, 2. I just babysat my niece a little while ago, so I watched some Sesame Street. Just 2 arguments, right? However, when I add this dot call, how many arguments are there? Oh, that didn't work out well. How many arguments are there? 1, 2, 3. Right? So I added an additional argument. The first argument I always want to add will be what this keyword will be. For example, notice how when say name was invoked by itself, what was the this keyword? This.name became empty string because this is what in the say name context? It's the window. Right? So if I want this to take on anything, I want this to take on additional attributes or something else, not the window, I can pass it in. And what is person one? The name is Andy. So naturally, if I invoke the dot call on say name and I pass in person one, what is this in the context of that invocation? Person one. The first argument is what this will be in the call. Cool? I can pass in what I want this to be. So again, say name dot call, passing in person one. What is this in say name dot call on line, the highlighted line? It's person one. So if person one is the this context, what is this dot name? Andy. So say name dot call with person one and the two regular arguments the function is looking for will be this dot name, which is Andy, says hello from argument one at argument two. Cool? Call will invoke and bind the this to whatever I pass in. Each one of the arguments within call are comma separated. So if they're looking for two arguments, I'm going to put two arguments separated by a comma. It will invoke and bind the this keyword. It will invoke and bind, meaning this function invokes, call invokes the say name function. Let's take a look at apply. Apply will also invoke and bind the first argument. But let's take a look at how apply works. How many arguments did say name want? 2. However, I'm passing in one argument as an array. And if I know it needs 2 arguments, I pass in 2 things into this one array. Therefore, apply will take this keyword you want to bind to and an array of all the arguments that you want. So person 2, that is what this keyword is binded to. Therefore, say name dot apply with person 2, and person 2 has a name. So when say name is invoked, because apply invokes, say name, this dot name is the first thing you see, and person 2 is this. So what is this dot name in person 2? John. So John says hello from New York, greatest city in the world, at 5 p.m. So the difference between call and apply here is simply how many arguments do I pass in, or would you like it in an array? This is only useful, again, metaprogramming, just think abstractly. If I don't know how many arguments I'm putting in, I can probably use the array, because I don't know how many I'm going to put in. But if I know exactly how many I'm going to put in, I can probably hard code those values. Cool? If you want to look at some source code, jQuery and a couple other things, we'll use this. Yeah. That's it. This is the only difference. Are there any questions on call and apply? Awesome. So let's talk about bind. Bind will set the value of this, but will not invoke. It will not invoke. It will not. It will not. I watched The Room recently too, like a few months ago. I did not hit her. So, bind will not invoke. What that means is, if I put sayname.bind with, what do you think person 3 is in this case, in the context of .bind? It's what I'm gonna set this keyword to in sayname, but it will not invoke it. It will simply return a copy of that function with whatever I passed in, binded to this. It will replace this keyword. Therefore, I can simply set a variable to what this is, to what sayname.bind is, and it will be a copy of sayname with this keyword binded. Therefore, bind person 3. Is this a function? Yeah, it should just be the exact same function. However, it has this keyword binded. So let's do that. All right, and it runs exactly as a promise. So what is bound person 3? It's that function. Just like say name is that function. They look the same. Let's check. Oh no. I said they look dang it. Failed me. They look the same. But are they? They're not. And it's because bound person 3 has this keyword bound to something else. It is a new copy of the original function with this keyword bound. Therefore, if I were to do bound person 3 and I invoke it with what does it need again? A location, right? So Flatiron School. And what time is it? Game time. Cool. And it says Gary. It says hello from Flatiron School, which makes sense because person 3's name is Gary. It is bound to that function. Are there any questions for bind, call, and apply? Yeah?
Why was this, when you didn't set it yet, like just an empty string as opposed to undefined?
That makes a lot of sense. By default, the window, this .name is an empty string. By default, on any like fresh page load, it's always empty string. If you use something, and we won't get into it, if you do something called, oh, I'm not using it here, like use strict mode. Have you ever seen this before? Use strict mode? Okay, use strict mode, it will prevent you from accidentally calling the global object, because very often you will not be calling on window. You shouldn't really be calling on window. If you use strict mode, it will change this keyword to undefined. It's just one of the things it'll do. So it prevents something like this happening. Cool. Are there any questions on bind, call, and apply? Great, let's move on. Boop, boop, boop. Great. All right, we're gonna talk about, before we get to our function, let's talk about this keyword. And let's answer Dan Abramov's question. Cool? So what is his question? It's object.method versus setting a variable to the method and making a reference to that same method. Remember, objects are passed by reference and not by value. So in example 2, you're not making a complete separate copy. You're referencing the same function. Does that make sense? In example 2, you're referencing the same function. Objects are passed by reference. So let's take something that we know works. Let's do this again. Actually, where is the function that was cool? There we go. There's some fave snacks in here somewhere. There we go. This is the arrow function. We don't want to get there yet. Let's do this. Bloop. Just change it to not an arrow function. Right? We'll just put function keyword. Bloop, 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 bloop. Are there any questions on this? Are there any questions on the angry chef object? Right? Angry chef dot chef name. We cool with that? And angry chef dot cook food. What do you think will happen when I invoke it? Oh. I didn't pass in food as an argument, correct. I feel dumb. See what happens when you make all these JavaScript errors? Nothing, really, because you know what's wrong and you could just fix it, right? Don't be scared. Cool. And this is just food item. Thank you for helping me debug. Sweet. Doop. And let's put in something here. Bananas. You cook your bananas? That's bananas. All right, that was corny, but I'm also corny. Cool. So this object.method is simply the object angrychef.method, which is cook food. So far, so good. What I can do is I can literally do var, right, method, right, or something else. Let's just put laptop for funsies equals to angry chef. Notice how this is not being invoked. Is that correct? It's not being invoked. So I'm simply going to pass in a reference to this function. So dot cook food. This is going to be a reference to the function. I should change laptop to reference to function. Cool? So if I do something like reference to function, I see exactly what I think I would see. And I can even do a triple equals to angry chef dot cook food. And it says true. No one should be surprised. This is like day one JavaScript, right? Objects are passed by reference and not by value. So if I were to invoke angry chef dot cook food, and I pass in bananas, sure. I get Chef Gordon Ramsay is cooking food. What do you think I will get when I invoke reference to the function passing in bananas? Just think about that for 2 seconds. What will happen when I invoke this function with bananas, or oranges, or peaches, or apricots? Let's find out. Boop, boop. And let's put, I don't know, I'm hungry. Halal food. Cool? Undefined is cooking halal food. That's weird. Only it's not, because of the context of execution for this. Here's what's happening. Object.method. The key word is the dot operator. Cook food is being invoked as a method to this object. Therefore, this keyword in the context of execution here, what is this in the context of execution when that line is invoked? It's angry chef. However, reference to function. Is this a method call on a separate object? Is blank dot reference to function happening? Or is it just reference to function on the global? It's reference to function on the global. So what is the this keyword for reference to function? It's undefined. Technically, it's the window, right? It's the window. Because you're really calling reference to function on the global object, which is window. We've talked about this. And what is window.chef name? Undefined. So, back to Dan Abramov's question. Do you see a difference between object.method being invoked? Simply making a new reference to that method and then invoking that method on the global. Do you understand how this keyword changes in its context of execution? And who feels comfortable with the difference between example 1 and example 2? Awesome. Great. So, nailed it. Answered Dan Abramov's question. Let's tweet at him like, yo, got you, fam. Hire me for React. Let's talk a little bit about the arrow function, right? It's important to note that all of the functions that I've been writing have the function keyword, right? I haven't wrote any arrow functions. So far, so good. 0 arrow functions. It's because when I use the function keyword, it creates its own this. The function keyword will create its own this. So, as important as I've highlighted that, the arrow function. Do you think the arrow function will create its own this? I mean, that's just a shot in the dark, right? That's just a guess. And the answer is, you are correct. It does not create its own this. The arrow function does not create its own this. This is so important to know. Function keyword creates its own this. Arrow function does not. Does naughty not. Cool? So, let's take an example. When I write something that looks like an object, I'm trying to avoid the this keyword. When I write const this arrow and assign it to an object, and I put say this, it invokes in that manner, right? This arrow dot say this. So far, so good. Notice, is this an arrow or a function keyword? It's an arrow. Very good. Elmo? This is an arrow. And I told you that the arrow functions do not create their own this. So, if I simply return this, who thinks that in the context of say this being invoked, the this keyword is this arrow? Great, that's correct. Nobody. Because the arrow function does not create its own this, it will inherit what this is. And what is the context of execution for this on this arrow? The global, which is window. Therefore, if I return this and the arrow function is inheriting the this keyword, this should in fact be the window, which was different if I put the function keyword here. If I put the function keyword here, what will this be? This arrow. Are there any questions or confusions as to how the arrow function is different? Also strict. Yeah.
Is an arrow function always past our reference? Is that why it doesn't?
The arrow function will inherit what this is, and in the same way that an arrow function is simply a function, which is a type of object, they are passed by reference. I want to say I thought I answered your question, but I don't know. Yeah? Okay, cool. Are there any other questions? Let's go. So this is just like syntax, right? Remember that this could be written the exact same way. Not really. This is bad. But I don't have to have curly boys, right? I don't have to have curly brackets, and I do not have to explicitly write return if it is a one-liner from yesterday's lecture. Yes? Yeet. Yeet. Yeets for cheats. Yeah?
Why would you use an arrow function in this context then?
What a great question. Why would I use the arrow function in this context? Let's get to that. Cool? So let's check this out. We have something, right, like const angry chef again. If you remember, before I used the function keyword, and it created its own this, right? Do you remember that? From like 8 minutes ago? Here, however, I'm going to use the arrow syntax. And as I said, the arrow syntax does not create its own this, and it will simply inherit. What do you think this will be in the arrow function? It will inherit from what it thinks this is, which was the window. So window.chefName is cooking food item. And you should in fact see undefined, because the arrow function doesn't create its own this. All right, that's that Zac Efron meme. You seen it? It's like, it's not sure. Cool. So far, so good. Now, this is where it gets a bit dicey, and we're going to start combining some rules. And here we can see there are two ways to do this. Let's do this in two ways. Let's do this in two ways. So we will have this is, let's put arrow eat snacks and regular old eat snacks. And this is just going to be a function. I'll just put a comma here so I don't break it. And I want to get stuck in JavaScript hell, so I'm going to do this. And I'm simply going to write the exact same thing. Oh, you're right. There is a for each. Ugh. Let's write this in JavaScript. And then I'll just copy it and paste it to the browser. Cool? Great. I'm just going to do this. Where is this? Cool. Just like that? Command Shift D. So we'll leave this. We'll make this the arrow. Eat snacks, and this is the regular. The regular eat snacks. It's just a function, except here I'm going to change that to a function. Boop boop. It's going to take in a snack. Cool. Also to note, I don't think I hammered this home. The arrow function, if there is one argument, you do not need to put the parentheses. Cool. So get rid of that so it doesn't look too crazy. Are there any questions as to what the main difference between these two functions are? The only real difference is inside the for each, I have arrow, and then inside the for each, I have the function keyword. It's the only difference. Watch the magic. Right? Let's take a look at this. Let's actually open index.html because I'll need to reference dog. So I'll do that. Bloop. I'll just open index.html. Cool. So now I should have access to dog. Cool. Any questions on that? Like, I should have arrow, fave snacks, name, regular eat snacks. So, that's not what I'm looking for. Let's analyze what's happening here. Let's talk about the this keyword, and then let's see if our guesses are correct. I see the function keyword here. Does the function keyword create its own this?
Yes.
Yes. Woof, right? It does. Therefore, on line 10, what is this referring to? The doggo, right? That makes sense. This dot fave snacks. So dog dot fave snacks will be this array. So far, so good. I can run for each on an array, right? Please tell me yes, right? It's like week 2, so. And I'm simply going to put in an arrow function called snack. Does arrow function create its own this? No, it does not. Remember, this is a callback function. This is a callback function. Therefore, inside the context and the execution of this arrow, which is inheriting what this is, which is the for each on this dot fave snack. If it's inheriting what this is, what was this here? Dog. So dog exists in here as this because the arrow inherited it. Check. Therefore, this dot name will in fact be dog dot name, which is Winfield. So I should see Winfield is eating snack. Let's take a look at that in action. Dog dot arrow eat snacks is a function. And I see Winfield is eating cabbages and carrots and bones, where cookies will not, right? Cookies does not like carrots. I've established this. Most important part of the lecture. Let's take a look at regular eat snacks, which is just the keyword function. Remember, function creates its own this. Therefore, the this keyword is pointing to dog. So dog.fave snacks is going to be array for each with another function keyword, which creates its own this. Therefore, what is this inside the function keyword right here? Its own this. Its own this. Which would mean that it's just probably going to be the window. Let's take a look. Doggo dot regular eat snacks is in fact like the empty string is eating cabbage. Combine those. The empty string, like window.name, is doing these things. Does everyone understand what's happening here and why you might want to use an arrow function in the way that it will inherit this? What you can do is on this function, you can bind doggo. And that will work the same as this, as lines 10 through 12. Sorry.
So like in that second one, you're technically like, you have dog and then it resets it and then you divide it again.
I'm passing in dog as the keyword for this inside of the callback.
But when you first started, you had access to dog.
Correct.
And because you have that function, it like reset this to the window.
It did because the function keywords creates its own execution context and it resets this keyword.
So no matter how massive the function is, it will reset to the global execution context.
If you keep using function keyword, the function keyword will reset the context. It will create its own this. Therefore, yeah?
In the second one, you put function snack comma dog would work with other line.
Function snack comma dog, like this. And then I put dog.name. That should work out. But that's a little weird to pass inside the for each. This will work because for each, if you look at the docs, it doesn't work the way you think it works. It works because for each will take an extra argument and that is the callback, and you can pass it a second argument to bind what this is inside the for each. So actually it would be inside the for each a second argument. So instead of dot bind dog, you can pass in a second argument and put dog. This is what I'm going to bind it to. It becomes very confusing, but the idea here is that I can bind dog here and it should work. So you will hear the following, but understand what that really means. Because these are the same now, people will say that the arrow function binds this. Does everyone understand where that comes from? The arrow function will bind this. But it doesn't really. It actually simply inherits what this is from the previous function call or the previous method. Where? It's window right here, but inside, this is dog. Say again?
Why does arrow taken from the method but not the regular function?
Can you point to the lines?
Just the difference between the two. Why is it different? Why is the arrow function work for this dog, but the regular function doesn't?
Because I'm using the keyword function here, and it will create its own this. And therefore, if it's a brand new this, it has no idea about any of the previous lines.
So is the dot bind, is that just like a means of being more explicit about what you want to be, like depending on how nested you are?
Yeah. Dot bind would just be a little bit more explicit. However, if you understand arrow functions, you will see in production, no dot bind. You will very often see if you want to bind the this keyword in like a nested thing, you will typically see just the arrow. And people will assume you know why the arrow is used and how it affects the this keyword. So please understand the this keyword and this whole thing and the this context execution.
Can you bind to anything you have access to?
You can bind to anything you have access to.
And the way that JavaScript works, so when it runs over the code the first time, that's when it's going to bind it. So when it actually runs over the function, it'll already have been binded. Like it's not like
When it parses through,
yeah, that's when it's binding it, and then when you call it arrays, you bind it, or it's like when you invoke it.
When it's
actively bound.
when it's invoked, it will evaluate what this keyword is. So in the second time, so in the actual execution. At runtime, this keyword is evaluated. So let's take a look at some really hacky things that I want to show you, that I only have like 8 minutes to kind of show you. It's not that bad. And then we'll end this lecture. You got a question?
No, I was just curious, like the arrow works because you use the function keyword the first time. Could you technically like use the arrow the first time and then bind it right at the beginning?
Can I say again?
So that first one worked because you used the function keyword right after arrow means to like define the function, right?
Okay.
It has access to this.
Yeah. So this function right here has access to this.
Could you use an arrow there and then bind it right there? Or
Yeah, you can.
So it doesn't necessarily mean you need to use the function keyword, you just have to know that it's what it's inheriting from.
That's exactly correct. You do not really need to always use function. Just understand how function or arrow will handle this keyword. And now that you have access to dot bind and you understand it, you can essentially dot bind anything you want to this keyword, and manipulate your code as such. So let's take a look at what's happening here. This is a I need to clear the cache. This is a product called Babel. What I want to explain to you is that all of your code will almost always get transpiled back. Your ES6, your modern JavaScript, your ES 2015 will almost always get transpiled back to ES5. The reason for that is because of the browser wars that we talked about. And that is, in order to establish uniformity across all the browsers, there was a point in time where we've said, hey, this is how it's going to work. If you have new features like set, arrow functions, then you will need to backwards write your functions and your code. Babel will automatically take your new ES6 and backwards compile it. So let's take a look at how it actually does it and what's actually happening. Let's get rid of this bind dog because that will mess it up. Cool. So notice const becomes var. Because let and const are new, they're ES6, it will backwards compile. So take a look at what happens here. The function keyword, right, in the arrow, notice it does something like this. It does line 7. And that is var underscore this equals to this. It is the way to save what this is for later. So inside, because remember the function keyword, right? This .fave snacks, which is still dog, for each. Did I write the arrow or did I write the function keyword? Because the arrow syntax does not exist in modern JavaScript, it will backwards compile it back to the regular function keyword. However, it will console log. You see this fancy string interpolation with the backticks? Does not exist in ES5. It is literally a bunch of string concatenation. However, in order for this keyword to have been inherited, it is saved on line 7 and utilized on line 10. That's how it knows of this keyword from before. That's how the arrow function is essentially sneakily inherited. What you will see in your Stack Overflow, and the only reason I'm explaining this is because as you look up questions on this keyword, you will see Stack Overflow comments doing something really hacky like the following. Oh, dang, it doesn't want me to. It will replace underscore this with the word called that. So you will literally see var that equals this, and then they will call that dot name. This is where it came from. It was so unreadable, even though you needed to do it because ES5 did not have the ability to inherit this keyword. It was so unreadable that they were like, you know what, we need to create something that can handle this, that can handle the inheritance of this keyword. Or instead of that equals this, they would put the dot bind. That was the workaround. And that's why it exists. This is like kind of like the history. So I just want to point this out because if you see it in Stack Overflow, which you very likely will as you look into this keyword, you'll see it. And you're like, wait, that equals this? The that? That is where that is coming from. And it looks tricky and it looks hacky, but it was really the only way to do it. Are there any questions on this keyword, the context of execution, function creating its own this?
So when is it beneficial for this to refer to the window? When you use that,
Never. Almost never.
Babel is basically anytime anybody pushes anything to production with JavaScript now?
Typically, yes. You will almost always be running Babel. It will backwards compile it, and then you'll do a bunch of other things to your code. Right? You'll uglify it, and you'll minify it. What that means is, like, as human beings, we love the way this reads. But as a computer, do you need the space here? Can you debug this code? That's terrible. All right, this is known as like uglifying and minifying. It's like, I'm just getting rid of all the spaces. They're essentially irrelevant. It's only for like readable code. Like, could you debug something like this? You'd be like, no. Come back to me with the indentations, please. Right? Get out of here with that. Like, look at this. No way. I'm in JavaScript hell with the indentations. So the idea is, yeah, typically, your React 100% will go through Babel. It is a way to store. It is a way to store something for later. Typically, whenever you see someone using like underscores, like underscore var equals to like something, typically this is like kind of hacky. You will start to see as you get into the source code of things, you will see a lot of like underscore var underscore. It is because if it ever gets overwritten by the user, like if you as a developer ever use something like, you'll see this later, proto underscore, you cannot claim you wrote that by accident. You like literally monkey patched the source code. And that's fine if that's what your app needs, but the idea is that it will break certain functionality because you've monkey patched it. And the idea is that how can I write something that is so difficult to overwrite by accident, yet still be readable? And so that's kind of, when you see a lot of source code, it will be written like this. And that is because no one's ever going to be like, oh man, a new variable, var underscore Hamza underscore. Never, you know? If you overwrite source code by accident, you're doing it on purpose. And that's really the idea behind it. Good question. All right, if there's no other questions on this, or this keyword. All right, cool, that's all I have for you today. Thanks.